My name is Joris Fields, and this is another edition of 3D Printing News Unpeeled. Now, the first item of news is, well, it's something unexpected, I think. I didn't think of this, and we've never discussed this with anyone even, so this is wonderful. We've heard a lot of times about 3D printing for things, underwater things like, for underwater operations and stuff like that, for pipeline repair, divers, that kind of thing. We've talked about 3D printing for ships, repairing ships and oil platforms and stuff like this. And but we have not talked about, in my opinion at least, so far, about 3D printing for tidal wind generation. And this is a fantastic opportunity that I had never really thought of. So, the National Renewable Energy Laboratory, NREL, has worked with the Pacific Northwest National Laboratory on marine energy technologies and 3D printing. They're doing this as part of this thing called the Powering the Blue Economy, which is the idea of getting renewable energy resources, that kind of thing, to work for us. Um, and the thing they've settled upon is a thing called tidal turbine blades. Now, this is, of course, a fantastic thing. It's one of these technologies that has always been kind of on the cusp of getting manufactured and really working, and ends up never really being commercially viable so far. But tidal energy is just powered by the wind, by gravity. It's abundant, super abundant. You can see it anywhere you can go to the ocean and stuff like that. And it could really bring energy as well to a lot of places where maybe they have too much or too little wind energy or not enough sunlight, or these things are intermittent. And the beautiful thing is the tides, of course, they're you can count on them, for the large part. So it's a fantastic dreamt up energy source, but it's never really quite happened. Now, maybe with 3D printing, it could. So what the guys have done is really use DED. They got AI build to make them a turbine blade spar. Now, this is fantastic because like people have been making turbine blades and turbine blade spars generally with additive for decades, and they make and repair tens of thousands of these every year. So this is actually something that if they want to really get to it, they could get a lot of expertise on. But now, for now, it's AI built that made them like kind of a bunch of test things for this out of stainless steel. Maybe they could get into a bronze material at one point, and maybe that'd be better. But for now, it's stainless steel. And what they're doing with it is they think that using DED, they could just iterate quicker. They could just try out bunches of these different spars, produce them really quickly, and iterate, and then just maybe come up with a better one. So that's awesome. They're now going to put 1,900 pounds of force with it, about half as much as it's supposed to withstand. And then also they're going to do fatigue testing, which I think will be a bit difficult, but that's great. And yeah, like I said, this is a new application. We haven't really thought about this, or at least I haven't, and this could be very big if it works. So I think it's wonderful to pay attention to this, like this in the coral thing as well as 3D printing coral reefs. These things that are kind of left of field, but they could become very big if it just works. So props to AI build and NREL for getting us into this completely new area. Now the next thing is Aerojet rocket giant, now part of Harris L3, has been contracted to do Gamma H. Gamma H is the Growing Additive Manufacturing Maturity for Air-breathing Hypersonics. It's a really important project for the United States of America. Hypersonic glide vehicle, so not a missile that goes up and then comes down and then could achieve a hypersonic speed. That's not really that interesting because the thing is, the missile goes up and you see it, you can track it the whole time. Like a hypersonic glide vehicle is capable of controlled hypersonic flight, which means you can go down, up, sideways, all over the place and kind of surprise you. And it can surprise you in a matter of hours in Beijing or New Zealand, right? And this is like, I've called it the ultimate new high ground. And if they can make this work, this is a really, really, really important capability. There's a bit of a confusion that some hypersonic things that go hypersonic, namely missiles and rockets, aren't really very effective, which is true. But this could be very, very effective, very, very important. Imagine putting a taskable satellite over a war zone very, very quickly, or getting a payload or a sensor or some troops or something somewhere on the edge of the world very, very quickly. And this is the technology that can do it. It's a new superiority in space. The Chinese are working on it. The Russians are doing some stuff on it, and no one's really figured it out. This is a $22 million project, which in the hypersonics world is not going to get you that much, I'm afraid. They're going to work on it for 36 months, and they're going to work on the scramjet component. What they're trying to do is get better part yields, reduce processing steps into one, which of course is better for your error rate, better for your for all the for just the operational efficiency of what you're doing, and they're just trying to produce these things faster and lower cost. A really nice quote by Keith DeVries, who is the Deputy Director of the Office of Secretary of Defense Manufacturing Technology, is we need to be pushing the envelope with materials produced using additive manufacturing. Science has proven to be it's possible, but the practice is not widespread enough. Gamma H will encourage further adoption of this groundbreaking technology. That's absolutely wonderful. This is the thing to watch. This is the biggest game in town. This kind of experimentation and making this work and just making stuff for the Air Force generally work is one of the biggest funding mechanisms for 3D printing. Like if you're looking lately over the past couple months, who's putting money into 3D printing? The U.S. Air Force is doing a better job than all the VCs and public markets in the world. So this is a bit of a a risk because it's a militarization of our technology, but also just an opportunity for people that are able to make hypersonic vehicles, make high temperature alloys, make high temperature ceramic structures and things like that. So that's what we're going to continue for, bring you the hypersonics news. And the next news is also rocket based. That's another area where we've made a lot of impact. 3D printing can make rockets faster, cheaper, iterate quicker, get them out the door quicker to clients. And that's why all the major commercial rocket companies use 3D printing for their propulsion stages at the moment. And now the ISRO or ISRO, the Indian Space Agency, has also 3D printed a rocket, and it's actually kind of a rocket engine. It's also actually kind of a very important rocket engine. They did a 665-second test a few days ago on the PS4 engine. The whole thing is made in India. It's made out of one piece. It used to be 14 pieces, so they did a lot of part consolidation, make one piece. They've saved 97% of raw material, which is a big deal for these guys because the raw materials are very expensive, and the production time is 60% cheaper, which is, of course, also a really big deal. Now, this is just not some testy McTest thing or some fun thing. No, this is the engine, which is in the reaction control system of the first stage of the PSLV. What's the PSLV? It's the Polar Satellite Launch Vehicle. It's one of the most important rockets in the world because it could establish India as a very cost-effective launch provider, which could mean that it could launch military things very cost-effectively and well. It could launch a lot of military satellites and things to gain an edge over its peers and near peers and competitors. But also, India could become a satellite power for its own good by launching all sorts of satellites for its analyze its agriculture, study its cities, that kind of thing. But also, it could become a launch provider at scale, in competition with the United States, in competition with SpaceX and the Falcon, in competition with the Russians and Arianespace. And it could be a bona fide, low-cost launch provider for satellites. It could just do exactly the same thing we see the Falcon doing. So that could be insane because it could mean that there could be a very viable Indian space industry that can consume billions of dollars that is independent or partially independent of the U.S. space industry. Which also means that the U.S. is the regulator, in effect, for most of the commercial space industry, but of course not all of it, not for India, and also not for the Chinese bit, not for the Russian bit. So this could be a win for independent countries. It could be a win for the developing world, if you will. It could definitely be a win for the people of India. There's something to be very, very proud of if they could do this. But also it's a bit of a risk for allied countries, if you will, that you have somebody who is on your side most of the time, who has their own launch capability. And also it's important to note that the Indian space program relies very, very heavily on Russian technology and science and materials and things like that. And so a win for India could be a win for Russia as well. And that's not something anybody that wants. Now, so, a little bit of a kind of, yes, we have to watch this news. It's very, very important. Is it universally good? Probably not. But hey, it's a hell of an achievement for them to do this, and it's a hell of an achievement for them to want to put this thing into production, because that's what they're going to do. This is not some test. They want to actually put this thing on these rockets, on that super important rocket that is either going to make them a champion in the launch services and have them have their own launch service industry, in fact, which will help them militarily and help them commercially to no end, or it could be an extra risk for them. So this is a very, very big deal and very, very notable news from the ISRO. So in addition to lightweighting this thing, in addition to reducing it from 14 parts to 1, they also eliminated 19 weld joints. I'm so happy to see that because that, of course, eliminates that manual step that could cause an error. Not only could it cause an error, it can cause an error very late in your manufacturing process, very close to your launch window or something. So that's also another thing that it did that helped. And overall, they would need 565 kilos of forgings, and now they only need 13.7 kilos of metal powder. So that's actually wonderful. The only company named with this is Wipro 3D. I'm probably sure it took a couple others to do this and stuff, but I'm not sure who would do it. But hey, good news for Wipro if they made this happen. And that's it for today. This is 3D Printing News Unpeeled, brought to you by 3dprint.com. My name is Joris Spiels. You have a great day.